Three.
Hello, my name is Caleb West. We're the optometrodynamical guys. And that would be me, Dylan Hamilton, Parker Heidel, and Jimmy Smith. And this is Project Armadillo Cyborg. So our problem statement, we were tasked with designing and building a Lego robot to solve a maze made up of black tape on a white background. Design functionality. With our design, the robot utilizes a reflectance sensor to gather data from the ground in front of its tires to determine if it is on the line and correct any changes along the line. Additionally, our robot signals what action it is performing using LEDs, a servo motor, or a combination of the two. I will now summon Jimmy Smith for the next slide. Sorry, Parker Heidel.
Hello. Thank you. So, here is our robot when we first designed it. It is a mess. Everything here is barely hanging together. Here we have a good robot where it is much more structurally sound, and we actually have a spot for our battery to go. This is our CAD for our robot as of right now. Here we have a shell that would be going over our robot to kind of make it an armadillo. This is this is a head that Dylan expertly CAD'ed to fit on the front of our robot. It will also be where the LEDs are mounted to our robot. In the back, right here, you can see a little tail. This little tail is used to wag. It wags its tail when it reaches the finish line.
Wow.
So yeah, it is such an amazing robot. And unfortunately, the shell may not be printed by the time competition happens, as it will take 4 days to print and competition is in 2 days. All right, I'm gonna hand it off.
Thank you, sir.
I'm gonna pause it.
Here we go.
Okay.
One more.
There you go.
Alright, so I'm talking about the test, so the process and issues we had. So when testing our car, we found that the front two wheels, they weren't getting any traction on the ground. Our turns, we didn't have enough friction on the back because of the roller thingy. So it would slide out and drift out. And one of our motors didn't put out the same value every single time. It was very inconsistent. When testing our car LEDs, they kept falling out a lot. Wow. The motors were loosely connected to the car, so our wheels would go in. And then whenever we were testing it, we had to change the batteries every 2 minutes. Every 2 times we did it, it wasn't that great. And the way we tested it, we just changed a little bit of the code each time. We worked on the left turn function, we worked on the turnaround, all that type of stuff. So I will be giving it to Dylan Hamilton for the next slide.
So next what we got is basically all the improved aspects. And so the biggest thing is first, initially, our entire robot, as Parker kind of talked about, didn't work whatsoever. And so we had to completely redesign. So that's the first bullet you'll see, redesign the entire car. So next, we had to change out our ball bearing because it was giving off too much friction. It'd be fishtailing like crazy whenever it's on the track. And so we just had to basically put and provide more friction by literally replacing that ball bearing entirely with Lego. Third, we had to change out one of the motors because it just wasn't working. Fourth, we secured each of the motors with what ended up being 4 zip ties. So they're very, well secured on each side. And then next, the LEDs, because they weren't soldered, were falling out all the time. So we ended up putting electrical tape there. And then finally, the biggest issue turned out to be we put rubber bands on the wheels because the wheels weren't touching the ground after we had improved everything. And that ended up fixing the vast majority of the car. So That's Project Robot Armadillo Cyborg thing.
What?